Derivatives. Now this is example 8 from lesson 13. As I said before, this lesson's broken into 2 parts because there's a fair bit of work to do. Now in this one here, I actually think this is a revision activity. You may remember one of our examples, if we go back here, we were practicing sketching the gradient function of, and the gradient of the gradient function of this function f of x and g of x. Now if you haven't watched this video yet, please go back and watch it, because this is sort of the key information how to sketch these. And once you've done that, I want you to basically work through these. So pause the video and then press play when you think you've got all the answers. Okay, so here we go. We're going to go through all the answers here. First thing is you want to find your stationary points. This is where you're looking for min, max, and horizontal points of inflection. So they're really important to find. Okay. Second, I'm looking for my vertical points of inflection. And third, I usually list where the graph is positive and negative gradient. Okay. Now, normally I draw pluses and minuses on this, but since you have the ability to, I'm actually going to highlight them instead, just to show where it should be positive and where it should be negative. Now, what I mean by that is, and you may remember from that last video, positive gradients should be on the positive axis, and we've got negative gradients on the negative axis, and then if your gradient is 0, it should be here. Okay, so this is 0, positive gradients up here, and negative gradients in this region. So let's go. Step 1, stationary points, find min, max, and HPI. Okay, so here we go. Min, max, HPI. Here's one, no HPIs. Okay, so we've done that. Vertical points of inflection, that's probably going to be one around here, maybe around there. That's probably our VPI. We've got a max here, we've got a min here. Then my next bit is I'm going to go, okay, highlighted in green, that's where my graph is positive. Highlighted in red, that's where my graph is negative. So we're expecting the positive regions to be above the x-axis, above the x-axis in the next graph, and then below the x-axis in the next. Okay, so here we go. So vertical point of inflection, we can see this is the steepest positive, and gradients here are 0 for these ones here. So what I do, draw a line down, dot here, line down. Using a ruler is probably best for this. We know the gradients there are 0, and this is, y dash, or the gradient function down here. And we know the VPI is the largest positive here, so I'm going to guess here. We shouldn't really have an axis here, because we're estimating this. Now, good, we've got those points there. I've drawn them in. Now let's look at our gradient. We know it's negative over here, and it's negative over here, and it's positive in this region. Therefore, what kind of graph would this make? Something like this. There we go. Okay, now we're going to fly through these a bit faster now. There. And we've got a VPI here and there. Positive here, negative here, negative here. Okay, that goes there. That goes there. That goes there. VPIs, that's the most positive here, most negative here, and then we fill in the rest of the graph. Next graph over here, find our points, turning points, VPIs, okay, and then we'll highlight positive the whole way. And so there's only one negative region in this graph. Okay, let's copy them across. We should have one here, one here, one here. VPIs, most negative here, and most positive up here, like that. Okay, now we've only got one negative region in there, so that means everything else has to be positive. So it must dip down, go up. Now, since this is staying positive, it must bounce here like that. Okay, now this key point here, do you see this region here? This is an HPI, right? It's positive here and it's positive there. So therefore, we're expecting this graph to stay positive and it must just bounce here at a gradient of 0. So it's basically bouncing on the x-axis. Okay, so HPIs bounce on the x-axis, VPI is the steepest gradient, and min and max just go stationary points. Let's go into these next ones here. Okay, now you're welcome to pause the video again, have a crack at these, and then press play. Okay, so we need to do an axis here firstly. Just draw them in. And this is going to be dy by dx. Draw this one as well. dy by dx. This is x. Find our key points. There, 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 there. They've actually labeled the VPIs in this one, which is very kind of them. And let's highlight where it's positive, positive, positive. I've got negative and negative here. There, 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 there. There are all my stationary points. Let's put in our VPIs. So steepest negative there, steepest positive here, steepest negative here. Okay, now let's just fill it in. Okay, next graph. Stationary point, oh no, it's not stationary points, it's x-intercepts. Stationary point, stationary point, stationary point, stationary point, stationary point. Put this here, 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 and here. Then we've got our VPIs here, 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 and here. And let's highlight positive here, here, negative there, there. And now let's do our VPIs now. Steepest negative is around here. Steepest positive is here. Steepest negative is around here. Steepest positive is around here. Okay, so now let's fill in our graph. Now I've drawn these arrows as continuing, so I'm assuming these are continuing like this. Okay, now you can see here I've made these quite sharp, so what you might want to do is when you draw them, just see if you can, if you have time in your test or whatever, just to try to smooth those out as best you can, because we know it's meant to be like a gradual increase, nice and smooth and continuous. Thanks, I hope this video was useful on how to sketch the gradient functions. Okay, thank you.